In this video we're going to learn how to make this trails effect in Blender in less than 8 minutes. First we're going to set everything up and get model into our scene. Then we're going to make this trailing effect that keeps the last 20 or so frames of the animation. Then we're going to get some of the information from geometry nodes into shader nodes to have a logical connection between them. And then we're going to finalize all of the materials, settings and camera. To start, go to mixamo.com, go to Characters tab and pick a model. I like this one because it's simple and doesn't have any unnecessary detail. Go to Animation tab and type Dance. Select any one you like. Now press download and make sure that FPS is set to 60. That way the copies will be spawning 60 times a second, which will make effect a lot smoother. Download it and save it in the folder where you can easily find it. Open Blender. We don't need the lamp and the default cube, so we delete them, only keeping the camera. File, Import, FBX, and select the file that you just downloaded. Now look at how long animation is and set the end of the timeline to the end of the animation. Make sure that the frame rate of the scene is set to 60. Now our model is a little too dense, so add Decimate modifier in Subdivide mode. Set iterations to 2 and apply it. Now our model has around 4 times fewer polygons, which is a lot more manageable. Now make sure our object is selected. Open Geometry Nodes tab, press New. Go to Frame 1, add Simulation Zone and join Geometry Node. Connect it like you see in the video. This setup is just going to take the geometry it gets from the dancing mesh and save new geometry each frame. This animation gets really heavy really fast. We have too much geometry after just a couple of seconds. So let's make it so that all of the geometry that was added X amount of frames ago gets deleted. Store named attribute, name it age, make its type integer. Name the attribute integer age. Math node add 1. This will increase age of existing geometry by 1 each frame, starting at 0. Connect math node output into value input of the store named attribute node. Put that stored named attribute into the simulation zone like you see in the video. Add delete geometry node. You can run that connection from here, but I like to have it separate. I feel like it's a little more readable. So named attribute age greater than 25, connected to delete geometry node. Now we have our animation with copies of the last 25 frames. I'm going to arrange the nodes nicely so that they are more compact and readable. This is how the whole node tree looks. Now let's go to materials and keep the original instead of creating a new one. We are going to delete everything except for an output. Add emission node, attribute, type age. Now just to preview and understand what is happening. Divide, and in geometry nodes double check the length. In my case it's 25, so divide by 25. Invert the color. Connect it to the strength output on the emission node. With the current values, the newest geometry of the age of 0 will be brightest at 1, and the oldest geometry of age 25 will be fully dark. Now to achieve the same effect with just a single node, use map range from min 0, from max 25, to min 1, to max 0. This way the input value of 0 will become 1 and input value of 25 becomes 0. And everything in between will be linearly remapped to the range between 1 and 0. To preview and to know what it's doing, connect it to the strength input of the emission node. Now disconnect the map range node, it was just for demonstration purposes. Mix emission with transparent PSDF and use map range output as a factor of mixing between transparent and emission. Let's actually flip it back with the map range to min 0 to max 1, making the newest geometry darker and the oldest geometry bright, because bright indicates more of the second input of the mixed shader node and dark indicates more of the first input of the mixed shader node. And that's exactly what we need, because the newest geometry must be just emissive and geometry must get more transparent the older it gets. Geometry node. Map range, add backfacing. This will make back faces of all of the polygons fully transparent. Another math node, add layer weight. This node will make it so that geometry we view at a sharp angle gets more transparent the sharper the viewing angle is. Now make sure you're using cycles and increase the light bounces for total and transparency. This will allow us to use many layers of transparent geometry on top of shoulder without turning it completely black when there are too many layers. Use saturation value node, give it the color that you want, and connect the layer weight to invert color and then to saturation input. This will make the color less saturated when we look at it at a sharp angle. Make some adjustments to the material if you want. Make sure that view transform is set to Chronos, because it keeps saturation pretty well and it's good for abstract renders. Maybe medium high contrast if you want. Now set the world to be completely dark. Add a plane, put it under our character and scale it up a bunch so that we don't see its borders when we render. Give it a simple material like you see in the video. Voronoi texture connected to roughness works really well to give it those nice imperfections. And that's the whole material. It's pretty easy to set up and gives us amazing reflections. Put the camera just above the ground, a few meters away from the character. Set the resolution of the scene to be vertical. I set it to 1080 by 1920. Adjust the camera rotation and focal length till you get the whole character in frame. Now we're going to make the camera automatically rotate to follow the character motion. For that, select a skeleton, go to edit mode and select the bone that you want the camera to follow. I selected the one under the neck. Now with that bone selected, go to outliner and press .delete button on your numpad. This will show you the selected bone. Copy its name and go back to object mode. Select camera, go to object constraints. Add track 2 constraint. Target, armature, paste the bone name and select the exact one. Put influence to around 0.8 so you can still adjust the camera rotation manually. In camera view, rotate the camera so you can see the whole object in frame. You might need to manually add some animation to the camera so you can still see the whole object in frame at some extremes of the animation. And this is it. Render it and see what you got. I prepared 2 example materials for you just so you know where to start, but be sure to play around with materials and find what you like. If you make something cool with what you learned today, be sure to tag me on Instagram. I would love to see what you make. Oh, and a small bonus. If you just animate the object moving around, it's not gonna work, because all of the simulations are done relative to origin point of the object. So when you rotate it, when you move it, the simulations move with it and rotate with it around that origin point, so you're not gonna see any animation. Maybe like this. Yeah, this will work. But to make it actually work, we do a trick I learned from Cartesian Caramel to force calculations to be done in global coordinates. For that, object info, self object, transform geometry, matrix, transform, and invert matrix, and this should be it. Now we can move it around, rotate it, and it works.